go back to look for the code that corresponds to the threshold of the objectness. OK， 好，所以呢，它这里面有个字，你要猜它的位置，还有呢它的信息度，啊，它到底是有没有物件 ？OK，up to now we still it's nothing to do with the class of the object, but we just care if this bounding box or this anchor will contain an object or not. Okay, plus. And here, how you calculate the box confidence score is the probability that the box contain an object and times the IOU. Remember IOU intersection over union 啊，这是实际的 ，OK， 实际的，跟你猜的 ，OK。That's the intersection, okay? Then over the union, okay? The IOU value is between 0 and 1, okay? Between 0 and 1. So this is the overlap, okay? The ratio of overlap, okay? Between the ground truth and the estimate, the bounding box, and times the probability that this bounding box contains an object, okay? So, and then you can calculate the conditional class probability that's given an object. Given I know this box contains an object now, and then further, what will be the class of the object? Okay? You know what I'm saying, right? Okay? And then finally, that will be the class confidence score that was given. Okay? The probability for some class I and times the IOU. Well, actually, based on the first two equations, the final class confidence score will be the box confidence score times the conditional class probability. But anyway, what we need is the objectness probability and the IOU. Okay, we need these two information to make our final decision. Okay. Okay, so just give the definition here, okay? The box confidence score. Let me say it one more time. The probability that this box contains an object and times the corresponding IOU, okay? All the value is between 0 and 1, okay? Well, I already mentioned what is IOU here, okay? And okay, that's the backbone of the YOLO, okay? The backbone, just a series of convolution, okay? That's it. Okay, anyway, the loss function, okay? Well, involves something like classification loss, okay, 分类的损失函数 localization loss, okay, the predict bounding box and the ground truth box, okay, and also the confidence loss, which is the objectness, okay, the objectness, the probability of the objectness, okay. That's what be the boundary. We look for a boundary value, but actually the output will between 0 and 1. Okay. I'll say it later on. Okay. Okay. Anyway, so here's how we calculate classification loss. Okay. The notation here first. This value should be equal to 1 if the object it appears in cell I. So you need to try to find out all the grid, okay, all the cells. It's S squared, that's because we divide it into S by X, right? Grids, okay? So we have a total S squared cells, and 1 will be equal to 1 if the object, which means the probability of objectness is high. Okay, otherwise we put it 0. Okay, if it's 1, then we calculate the mean square error. Okay, C is the class. Okay, C is the class. I is the cell. Okay, I is the cell. Which cell? Cell 1, cell 2, cell 3. Okay, okay. That's then the ground truth. Okay, if it indeed contain an object, the ground truth will be 1. Okay, the prediction, the value could be something between 0 and 1. Okay, because it's a probability. That's it. Okay. Well, in the original paper, you simply calculate mean square error. Actually, you can use what boundary cross entropy. That'll be fine. Okay. It does not have to be just use mean square error. Okay. Then the localization error. Okay. The localization of the bounding box is something. Again, you still need to set up this value. Okay. If the box contains an object, and then you return 1, otherwise it returns 0. Okay, then you calculate the difference of the coordinate. Okay, for this, it depends how you define the coordinate. Okay, could be in the center of the bounding box or the upper left corner. Okay, then this the width and the height. You use square root. You know, someone use what? You take log, right? And not do the normalization. Okay? So anyway, you can do a lot of things. You remember last time when we talked about we calculate delta x, then we divide it by the width, right? Right? That's another way. So that the value will be between 0 and 1. But from the notation here, apparently, it simply just calculate the x. I think this could be bad. This could be bad. Okay, and delta y then divided by h. Okay, delta x is the difference of x. Delta y is the difference of y. Then divided, and someone used tech log. Okay, then tech log. Okay, of the predict. But anyway, that's another way we can define it. Okay, then finally the confidence loss. Okay, then again you put it. Okay, the probability. Okay, the probability of objects. Okay, is 1 or 0. Okay, and then C here is the confidence score. Okay, of the box J in cell I. So you need to check for each cell and calculate the confidence score. You remember what is the confidence score here? So we mentioned here. Okay, the confidence score. Okay, first the probability of objects and times IOU. That's it. Okay, the confidence score. Okay. Okay, so because the expect value, this value got to be equal to 1, right? If it's contain the target object, right? And the IOU got to be 1, the expected IOU to be 1, and then this will be estimate. Okay, it all use mean square error. Okay, again you can use entropy, okay, to replace it. Okay, but I don't know. I didn't try it myself. It just not only measure the objectness. Okay, the confidence loss here. See that it measure the other term. If an object is not detected in the box, then it measure also the confidence loss, which is measure the background. I don't know why. What if we don't have this term? And it put another regularization locked up here. I'm not quite sure if we need it or not. 也就是说，他这边去看它是不是有 object， 可是呢，它同时又弄一个，假如它是 background 的话，那它的 loss 又是什么样子？听得懂？好像 I mean, it's a kind of redundant, but apparently it includes this term. it could be better, but I don't know why. Okay, I didn't try to. If you are interested, you might manipulate the original YOLO code. What you put lambda, see that if you put lambda equal to 0, which means this term is gone, right? 你念 lambda 等于0嘛，就不要看了。可是他这边又把它当 background 来看，它的损失，我也不知道到底必要性有多高啊。Okay, anyway. Okay. So anyway, the lambda could be 0. Okay, could be 0. Okay. I said it here. Okay. The original, the original proposal method used. Okay, but YOLO does not. Okay, does not need the original proposal, but it used the grid. Right? See that? It used the grid. Then you check for each cell. Okay, that's it. So it's a one-stage approach. That's why you work only once. But for original proposal, you need to look at twice. First, to look for the proposal, and then for each proposal, you look for the possible bounding, the object or the bounding box. Okay. So usually, overall, YOLO is faster than the RCM-based models. Okay. Okay. Now here's something I want to say because you see YOLO version 3, which means you will see YOLO 2 and so on. Now here's a major change, okay, about the classification, because YOLO have to predict, right? Once the objectness is 1, then you need to further to identify what is the class, right? So the logical or the reasonable output, okay, for classifying, if we finally, right, you have the region, you have the bounding box, then you have to classify. If you have a 10 class, you will have the 10 output node, right? Right? Okay, you use a one-hot encoding. Then what should be the activation function? What would be the reasonable activation function? It got to be softmax, right? Softmax. You will estimate the probability. You use softmax, right? So you will make the probability for class 1, probability for class 2, up to probability class 10. But now you know the summation of the probability must be equal to 1. Remember originally, I just showed you the image. The bounding box contains a person who is riding a bicycle, which means the bounding box, you might have 2 objects. One is person, the other one is bicycle. Softmax give you this information? No, because based on the softmax, you will only pick up the one with the maximum probability. So the output is either a person or a bicycle. That's it. You won't know there's a person and also a bicycle. You might say, I can lower the threshold, but then you will get a lot of trouble because the bounding box may not contain any object. Okay. So the YOLO 3, it does not use the softmax. Instead, listen up. For each class, you use the independent. When you say independent, which means each class has its own classifier. It uses logistic regression. That will be the topic for the data pattern class. Okay, I won't say anything, but it's a logistic regression. A logistic regression is a classifier, not for regression. Okay, 它用回归哈，叫逻辑回归了哈，叫逻辑回归。可是回归呢是做分类，不是做回归。Okay, anyway, logic logistic regression. Anyway, which means for ImageNet, for example, if we want to identify the class, how many classes in ImageNet? 1,000. 1,000, which means you need to build up 1,000 classifiers. So it's up to your application. Okay, you need to determine. Anyway, it does not use softmax. That's the reason, because each class will its own logistic regression or logistic classifier. So if the value larger than threshold, then let me assume 0.7, then you will know the cell will contain a person, and this cell also contains a bicycle. They are determined independently with each individual classifier. Okay, but you need to train. If you have a lot of classes, you need to train a lot of classifiers. For that, that'd be good. Okay, so that's the idea. Okay, that's the idea in Euro 3. So you can have a multiple output. Okay, you can have a multiple output because each class is identified by its own classifier, which is based on logistic regression. OK， 好，按用逻辑归，不用 softmax， 因为 softmax 这里面呢，全部加起来一定要等于1，你只会挑最大的那一个。那事实上你也知道啊，一个 cell 不会只含一个物体，有可能。Okay, that's the one of the major change here. Okay, here show you some basic Euro 3 architecture. You can take a look, but again, you can see still based on what the residual net. Okay, based on residual net. Convolution, residual. Okay. Here A means it repeats. Okay, repeat 8 times. So you can take each one as a block. 常常你会看到他写 convolution block 指的是里面有好多个 convolution pooling, batch normalization, blah blah blah. OK 那这个 A 呢是重复8次这个东西重复8次。OK, then it give you the number of filter and the filter size and the output. OK, then here's the output feature map. OK, that's it. OK. Okay, so that's something about Euro 3. Or you use batch normalization and use liquid red root. Okay, liquid red root. Okay, later on I will show you about Euro 7, Euro 4 something. Okay, it does not use liquid red root. Okay, we'll get into that later on. But anyway, Euro 3 you use liquid red root. Okay, you know what record? This is red root, right? Right. Okay. And this is liquid red root. Okay, but medium. Okay. Medium. And later on, it has been changed to something like this, right? Okay. Okay. If you are interested, you can go through the details. Okay. So anyway, let's take a look. Actually, for Euro 3, you might wonder how you take care of the scale variation, right? Now, when you take a look at the architecture here, here's the input, okay? Then you go through the baseline model, which is something like residual net, okay? But if you take a very close look here, okay? This is the last, okay? Convolution. Then you have another convolution in the medial convolution layer, and it has another convolution layer in the lower resolution, okay, in the early convolution stage. So actually it applies what? What? It's something like what? I mean, even it doesn't it doesn't use the pooling, but it goes for the convolution with the stride of 2. So you will downsize by 2, and then you will output the feature map. Then you do the prediction. So it's just like what? Mask RCN's feature pyramid network， 它一样做近似的，你可以看得出来，它上面嘛，当然它之前看了，可是它还是三角形啊，不要把它倒着，它越来越小，来，see that? Okay, this is how it predict the size. Okay, it does not use the bounding box with different sizes, but instead it can take care. So let's look for the last convolution layer here. See that? Before you make any prediction, it carry out one by one, again, carry out one by one convolution, okay? Then you do the prediction, okay? Prediction. So it's trying to predict what? A very large object. 因为这边已经是在这个 the image size has been reduced, right? By half each time. So it from this level, you try to predict a large object because a small object will be gone. You cannot see the small object, okay, from this resolution, okay? So, but at the same time, see that? At the same time here, you do the upsampling, okay? The output, you make the prediction for large object, but at the same time, the output here, you do upsampling and then concatenate with the upper convolution layer or residual layer. See that? See that? Do the concatenation. 它把它串接在一起 and then go through the convolution. And then you predict what? To predict the bounding box or predict the object of the medial size. And see that? After the concatenation, after the convolution, it goes back to the lower, okay, or to the upper, or to the early convolution layer. See that? Okay, then you do the upsampling one more time, and then do the concatenation of this output and do the convolution, and then do your prediction to predict what? To predict a very small object. So actually, it still go for the feature pyramid network. Okay, the idea is exactly the same. Okay, they use the same idea here. Okay, just like mask RCN. Okay. Okay, so if you want, we can just go through the detail and what are the number of filters and the filter size, blah blah blah. But anyway, these 3 levels will try to identify object of different sizes. Okay. Okay, and I already mentioned for each class you use a logic regression, and logic regression actually you have the shape of symbol. Okay, that's why it says symbol. 因为它就是 symbol 的方式 of the values between 0 and 1, between 0 and 1. So 2 per class, which means each class has its own logic regression. Okay, and the output actually is a symbol. Okay, symbol. So the bounding box, actually the final output will contain the box coordinate, right? The coordinate and the size, okay, the width, the height, and P. It is not. I should only to indicate as an object is better than 0. But anyway, it means it's an object. Okay, if this box contains an object or not. If P0 or P object indeed contain an object, then also you need to calculate what is the class, okay, the probability based on symbol, okay, for each class, okay, for P1, P2, and PC, okay. You know the summation of from P1 to PC will equal to 1 because it's identified individually for each class, okay. So which means a bounding box may contain more than one target object, okay, based on the output value here. Okay, here's the final output, okay. Location, object list, and per class symbol, okay, per class symbols, okay. Okay, so just keep saying, okay, you use the logistic regression, okay. Let me say it again, regression is not for regression, it's for classification. It's just the name 那个回归它不是在做回归，它是做分类 ，OK。Okay. Actually, Euro 3 it is based on a COCO data set, okay, not ImageNet, okay. Here, right here. Euro 3 will predict object in 3, as I mentioned, okay, I already mentioned here, 3 scales, okay, by using appearance, okay, and also you will predict 3 bounding boxes in each scale, or actually still 9, okay. 3 bounding boxes is related to the aspect ratio, okay. But this aspect ratio is determined by, let me see if you can see it. First, you use so you still need the anchor box. Okay, still anchor box. The anchor box, let me see, right here, okay, you will use the 3 anchor box. Now, actually, for different level or for different scales, the anchor box will be different. But for each level, you use up to 3, okay, anchor box. And the box size is determined by unsupervised clustering based on the COCO data set. It will group all the image in the COCO data set and divide it into 9 anchors or 9 boxes, just like this. Anchor box 1, anchor box 2, and anchor box 3. Okay, it's determined automatically by the COCO data set. Which means when you apply it for your own data set, you must be very careful if the COCO data set is good enough or not for your own application. Okay? 因为它用 COCO data set 它用分群的技术呢去找9个 the most possible anchor boxes size based on the COCO data set. Okay? So which may not be the best. But COCO data set contain most of the sample, okay, in your daily life, but I don't know if it's good or not for your manufacturing application, for example. You must be very careful. Okay. I will show you the figures later on. Okay. Anyway, so for it divide an input image into cells or grids, and then you use FPN, okay, to try to identify the object of varying size. And then for each size, it use up to 3 anchor boxes based on the COCO data set, okay? And by automatically you do the classing， 也就是它 COCO data set 里的资料呢，它自动分群，也就是说这个物体跟那个物体，它到底它把它分成9群就对了，分成9群 ，okay? And then this 9 anchors, well actually for each level you will use 3, okay, 3 anchors box, okay? So that the user does not have to specify the value. But for your own application, you might change the value, right? You can change the value, the anchor, the size. It does not have to follow the COCO data set, okay? It's right here, okay? I'm sorry in Chinese, I cannot find any English information about how they find this 9 anchors box, okay? It's in Chinese, but actually here's the line based on the COCO data set. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you can see the small one is 10 by 3. Now you can make a guess. This anchor box is used in which level? Right? Try to identify a small object. Okay? 10乘13. Now you have a very large one, 300. Let me take this one. 156 by 198. It is what? This anchor box is used at this level. A large anchor used in a small feature map to identify a large object. But the size here corresponds to the original image. Not the size used here. Okay, this is the size specified in the original image, in the original COCO data set image. 好，你不要看到说，你到这里的话，你看到它可能它的尺寸都没有这么大，你想说那它怎么报？不是哈，这只是它原来的，好不好？原来尺寸。This corresponds to the size in the original image. Okay, let's use the COCO data set, then apply the classing. Okay, it uses a simple k-means classing anyway, that would be algorithm. We are going to talk about next semester. Okay, but anyway, as it says here, okay, the size here is based on the input image of 460 by 460. Okay, so don't misinterpret the value. Okay, all the value here is mean the location, okay, or the region in the original image. Okay, so that's good. Okay, that's the only source I can find this line value here. So it means it's a factor of 32 compared with the original image. Okay. As I mentioned here, when you try to estimate the coordinate of the boundary box, here you need to do the normalization. Here, this is this term. Okay, px is this term. Divide and ty is this term. Okay, p is the width, the height, and then this is the ratio. Then you take log. Okay, then you take log. You do the normalization. Okay, do the normalization. Okay, so that's about some 3, okay? But here's the one you need, must keep in mind, okay? Feature pyramid network to take care object of different sizes, but it still need anchor boxes, okay? 好，那还是需要用到 anchor box 去做。好。Anyway, after Euro 3, then we have then comes Euro 4, and then Euro 5, and now Euro 7. Okay, I still have a little bit of time. I will talk about Euro 4 and say something about Euro 7. Okay, Jen had sent you the file, right? Yesterday. Oh, if not, you can. I think you can download it from portal. Okay, Euro 7. And here comes Euro 8, okay? But I prefer to talk about Euro 4 and Euro 7 because it really is more official papers, okay? To talk about Euro 4 and Euro 7. As I mentioned, Euro 4 and Euro 7 are developed by the same group, okay? Euro 4, okay? But it's okay if you still want to use Euro 3 or Euro 5. Okay. I myself indeed try out Euro 3, okay, for position, okay, to try to identify the location for alignment. I'm quite surprised, okay. The translation error, okay, in the X or Y axis is only about 3 or 4 pixels. 我很惊讶，你这在施工自己施工。I mean, I don't have to need too many training sample, but the accuracy about the translation is only 3 or 4 pixels. 它的误差它只有3-4个 pixel. But the problem is the rotation. Okay, rotation, because you cannot estimate the rotation of the object. But I'm quite surprised. Okay, it's quite accurate to identify location. And that's what I'm saying. The original developer of Euro 3, I mentioned that before. Okay, he claimed he no longer support or maintain the Euro model because he found out people use Euro 3 for military application, such as you can guide the missile, right, to attack hijacker or something. 因为显然那个 Euro 3那个作者有点反战啊。的确是啊，你现在任何东西，那就 for the missile or for the drone， 那个无人飞机啊，你真的你说随便装这个你就可以。I mean it's quite accurate. As I mentioned, I mean the accurate is very accurate. But anyway, the original author development in Euro 3, but someone developed or revised Euro 3. So here you see the Euro 4, Euro 5, Euro 7, and then Euro 8. Euro 8 is developed by some Russian group, and I believe it has been installed for some military application. Okay. And now the frame rate can be more than 50. Okay. Frames per second. Okay. It can be more than 50 and up to 100. Depends on what is the hardware you use. 它每秒可以侦测到50到100伏，那你就知道为什么那个速度那么快，它还是可以去做。Okay, it's quite fast. Okay, especially compared with regional base CN for object detection. Okay. Okay, so here's also another something you might want to know. Say single shot, okay, detection. Okay, if you Okay, but it is not as popular as Math Gaussian or Euro. So, or even is something. At some point, I already mentioned that we don't. Here's another one. Okay, it does not use any anchor at all. So if you are interested, you can take a look. If you are working on this research, maybe it'll give you some idea. Okay, but it's not as popular. Again, it's not as popular as Math Gaussian or Euro. Okay. Okay, just some more detail you can take a look. And here I give you a lot of detailed information about point rank. Method, and here is the point rank. You can see here, I mean the segmentation result. You can see the finger here. For this one, you can just see here's a hand. Okay. A guy's play tennis. Okay. But you can see the figure, right? Okay, give you a better segmentation. Okay. So the segmentation, it will give you some pixel estimation. So we add some more features for that. Okay. Not give the coarse estimation segmentation, but also it will give you the coarse segmentation and give you fine point features estimation. That's why you can make so accurate estimation. Okay. So. And then it adds some new features, some new idea. Okay, so and all the rest, I already mentioned the architecture. And okay, so that's about Euro 3. Okay. Okay, I'll stop here. I'll talk about the planet because Euro 4 will use this idea. Okay, I will talk about it later on. Then we will talk about Euro 4 and Euro 7 and can finish. Okay, and next week I will talk about GAN. Okay, and cycle GAN. Very useful. Okay, very useful. Even nowadays, diffusion model seems to dominate the image generation, but personally, I still feel cycle GAN could be the best image generation, especially for manufacturing application. It's fast, okay, and easy to understand. Okay, so just take a break. But before I go for the Euro 4, I will say something about the path aggregation network. Okay, PAN. Okay, let's take a break.